news! Welcome back to GMAC 9. A new method of production for the vaccine for hepatitis B has been discovered by Pablo D.T. Valenzuela of Chiron Corporation. We'll be joining his team today to find out more. Dr. Valenzuela, please tell us more about your latest discovery.
With pleasure. Through many years of research, my team and I have found a way to produce the vaccine from genetically modified yeast, specifically Saccharomyces cerevisiae. This new method of production will significantly reduce the risk of contracting the hepatitis B virus, whilst offering a significantly lower risk of vaccine contamination, as it only produces the antigens involved in stimulating the immune system to produce adaptive immunity.
Wow, that's fascinating. How exactly did you and your team engineer the yeast for this purpose?
We used a recently developed biotechnology known as recombinant yeast, where we modify the DNA of the yeast such that it produces the desired product. In fact, we were so excited about sharing the details of our research, they have created an infographic for the public.
From what I understand, to engineer this recombinant yeast, a section of DNA from hepatitis B virus has to be cleaved by a restriction enzyme. Then, this section of DNA is ligated into a vector known as yeast extraction vector PPIC9. Wait, then what happens after that?
Afterwards, the vector is inserted into a yeast cell through a process known as electrophoresis or transformation, where a high voltage shock is given to the yeast to stimulate the cell membrane, allowing the vector to enter. Heat can also be used instead of electricity in this process.
The transformation of these yeast cells can even carry on to future generations of yeast. When they undergo cell division, some of the daughter cells will contain the DNA held in the vector, allowing us to increase our rate of vaccine production exponentially.
Thank you for the detailed sharing, but all this information is getting a bit hard to follow. Is there any way that we are able to see the yeast in action?
Of course, we have also recently bought a stingray so we can meet our new creation in person.
Oh, there he is.
Hi, I'm recombinant yeast. Please hold on, I'm still in the process of creating some vaccine.
Let's take a closer look at this cell at work.
A portion of the transformed yeast DNA contains genes from a hepatitis B virus, which encode for its surface proteins. This portion of DNA is transcribed into an mRNA molecule by enzymes found in the yeast nucleus. This molecule acts as a messenger between the DNA and protein-synthesizing ribosomes of the cell, transmitting information which the ribosomes translate in order to produce the hepatitis B surface proteins. The surface proteins are packaged into secretory vesicles and leave the cell via exocytosis.
Okay, now I'm ready.
Oh! As you just saw, the surface proteins released by the recombinant yeast bind very strongly to aluminium. We use this property of the surface proteins to gather them, and these protein-covered aluminium particles are administered as the hepatitis B vaccine.
But that isn't the end of the story. Once in the patient's blood, the vaccine mimics an actual infection by hepatitis B virus, causing the body to produce antibodies in response. These long-lasting antibodies are what provide immunity to the patient.
Well said, Dr. Valenzuela and Mr. Keith. Obviously, you can tell that recombinant yeast has so many advantages. Just look at me. Firstly, the production of recombinant yeast is much faster and more reliable. Secondly, there is a lower risk of contamination, which could lead to drastic changes and infections. Lastly, it's so much cheaper to produce in bulk. What's there not to love about me?
Okay, recombinant yeast. Let's not get too cocky. We created you, so we know the limitations as well. The use of recombinant yeast poses an extreme risk to patients suffering from multiple sclerosis. The yeast may trigger the killer T cells of the immune system falsely, causing them to attack the body's own oligodendrocytes in the central nervous system. So, watch out!
Wow! What a comprehensive review to this new biotechnology. Unfortunately, that's all the time we have for today, folks. Stay tuned for the next session of GMAC News.